Okay, people are still walking in, but we are pretty much at time to kick off. But don't worry, if you're still finding your seats, you have like a couple seconds until the actual content starts. This is just me babbling here. Yeah, but welcome. Top new CNCF projects to look out for. Great session, a lot of Kubernetes, cloud native. Super happy that so many people are interested in the topic. Lovely to see you all here. And as always, I think it's super important to pay respect and be happy that we are all here. Thank you to the organizers, to the whole community, as well as obviously the sponsors for making this actual event happen and possible as well. So very much happy to have you all here, and thank you so much for having me as the organizers. So to kick us off, I want to start with kind of talking through what value do you get by attending this talk, because this session is a bit different from, 101 step-by-step getting started guides or anything like that. So we're actually going to be kind of fast-paced, very quick session altogether. But in general, the goal here today is to get inspired, hopefully. I can't decide if you get inspired or not, but hopefully there will be interesting things that inspire you to get started with different things. And the things that I want you to get started with or be inspired by are the cool CNCF projects that I'll be running through today. So that's the agenda for this morning. Lovely time. Yeah, so quickly, who am I and why am I here talking to you about this? So hi, I'm Annie. I'm a senior product marketing at Camunda, which is a process orchestration company. And I'm a CNCF Ambassador as well as an Azure MVP. So what those two essentially mean is that I talk way too much about the cloud, way too much about Kubernetes and cloud native around different places, so which is part of the reason why I'm also happy to be here today. I'm also a Kubernetes and CNCF meetup co-organizer for 5 years now for Finland. So I'm originally from Finland. I live in Zurich nowadays, but it's nice to be here in Sweden, though, close to my home in Finland as well. So that's always nice. I've studied Swedish for 10 years, but don't hold up on me any actual skills. The language always gets very rusty, but yeah. I'm also a startup coach. I coach early stage startups, and I'm also the co-host of Cloud Gossip podcast that you can find at cloudgossip.net. I'm also frequent the Kubernetes main event or biggest event, so the KubeCon plus CloudNativeCon program committee, as well as I host a weekly live for CNCF around new projects and open source projects in the sphere as well. So yeah, CNCF, I mentioned the word a few times already. It is in the talk title, so people should maybe be aware of it. But how many here have heard about CNCF before they saw the title? Yeah, okay, few people, perfect. Great, so CNCF is the Cloud Native Computing Foundation, which is on mission to build sustainable ecosystems for cloud native software. So it hosts critical components of global technology infrastructure. For example, the project that I'm talking about today. So those are really nice ones. So CNCF also is part of the Linux Foundation. And it organizes events such as KubeCon plus CloudNativeCon, but also, as I mentioned, the most important mission is to have a home for different cloud native open source projects and really helping those maintainers, helping those projects get started, and truly kind of supporting those communities around them as well. So that's the main mission. Yeah, so there is, I think, nowadays the impact of cloud native and Kubernetes in the world is kind of undeniable already. It's very much taking the world by storm. But I think it's very interesting. So CNCF does this survey every year where they ask people, okay, where are they in the Kubernetes adoption journey? Where is what's happening? What are they adopting? What are the challenges they face? And the growth of Kubernetes and cloud native has been absolutely booming, and you can see it in the survey as well. So by 2021 survey, which is the latest with the results, they are conducting the current one right now. 96% of organizations are either using or evaluating Kubernetes, and it's a record high. Obviously, the sample is a bit biased because there are people who are already kind of interested in this, but since the number keeps steadily growing, it obviously means that there's a trend there, which is really nice. And now, if you are new to the CNCF world, don't be alarmed by the next slide. It's a bit of a woozy, but this is how the landscape looks like. It's definitely something. There's quite a lot of things going on. This is why also this session is 50 minutes long, but this is all of like cloud native essentially landscape, and not even all of it. These are like most important projects. There's a lot others ones as well. So one could talk for like, I guess, days or even a week just like about this landscape here. But hopefully today we're going to take like a bit of a zoomed in look into it and not be so scared about it, as well as kind of really pick and choose what we focus on. Because as you can see, it's a big thing on one go. But if you start zooming in, it actually becomes very manageable and it's easier to approach from there. And a quick, like, easy way to look into this is, for example, through the different projects. So a lot of them were mapped there by their icons. But icons in CNCF, they can be divided into 3 different categories. So there's 3 different tiers that projects go through. So the sandbox phase is the starter phase. So if you are in the beginning phases of the open source project, just a few maintainers getting started, that's where you are there. Then you move on to the incubating as you mature, and then you move on to the graduated as you mature even more. And at the graduated phase, so that's a signal that that project is fully ready and mature for production into any sort of environment. So that's when the projects are really big, really stable, fully secure, everything's working. There are people who are using sandbox or incubating projects in production, but that's obviously you have to do a bit more evaluation yourself on does it fit the needs that you have and whatnot. And then this is another way into looking at the sandbox, incubating, and graduated. So you have the sandbox projects are usually used by the innovators and the techies, and then the incubating phase is for early adopters, and the graduated is for that whopping huge part of people there at the late maturity stage. So that's in there. So there's going to be a few projects in this session. I always try to pick and choose kind of wide variety, depending on, even if you're a beginner, you get something new that you can kind of easily get started with. So a few graduated projects, as well as a few sandbox projects, just if there's anyone who's like super deep into cloud native and here just to hear the latest and greatest, there will be something for you as well, hopefully. But as always, I'm not a fortune teller. I do not know the future, unfortunately. That would be kind of amazing to have that superpower. But I do not know exactly like what will be the biggest next thing. But there's obviously indicators. I can see, okay, which communities are active, which maintainers are really passionate about their project, which projects are really gaining attention, traction, because particularly in open source, the people are usually what makes the projects as well. So that's a great way to kind of predict some things as well. And expectation-wise, usually CNCF that has like introduction to a project, they are usually 30 to 45 minutes long. And this is obviously, well, not a shorter because it is a 50-minute session, but it's covering multiple projects. So there won't be a deep dive into any of these. It will be kind of, even at point, rapid fire, multiple projects. But hopefully, as I said, this will inspire you to get familiar with them deeper on your own time. So here is the reveal. These are the projects that I'm going to be covering today. So how many here has used Helm before? A lot of folks, perfect, but still a few who haven't used it, so that's really great though. Good that we have a mix of people who are maybe more beginner and less beginner, that's nice. So how about Linkerd? No one? Perfect. This is awesome. I'm super happy that everyone's going to hopefully learn something new. Well, maybe everyone knew about it, just haven't used it, but yeah. Kada, a few people. Perfect. Flux, 1, 2, 3. KubeVirt, no one. Kudo, no one. Meshery, no one. Kuberno, no one. Perfect. As you can maybe tell from this, the ending part is the more new sandbox project, and the beginning is the graduated. So here was actually quite nice physical representation on how the life cycle works as well as graduating towards the end. More people know the project, and towards the beginning, lesser known ones as well. So let's get started. So we have Helm, the package manager for Kubernetes, which is by far the most well-known project in this session. And it is nowadays almost pretty much synonymous with Kubernetes as well. So it's the best way to find, share, and use software built for Kubernetes. So Helm is the package manager, so it's kind of similar to Homebrew, Snap, or Chocolatey, which is for Kubernetes. And I think one of the Helm maintainers put it really well. So package management is tooling that enables someone who has a knowledge of an application and a platform to package up an application so that someone else who has neither of those, so they don't have any extensive knowledge of the application or the way that it needs to run on the platform, so that they can actually use it as well. So that's the power of package management, and that's why it's the power of Helm as well. There's a lot of benefits there. So Helm helps you manage complexity. So charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. So Helm also has easy updates, so you can take the pain out of the updates and in-place upgrades and custom hooks. And it has really simple sharing. So charts are easy to version, share, and host on public or on private servers. And you can use Helm to roll back to a older version of a release with ease as well. Now, what are the principles of Helm and what are the main ways that it's been built? So Helm takes security very seriously. It has multiple maintainers and multiple companies backing it, as it is a graduated project already. So there's all the fun stuff that comes with it. So power user, email list, release candidates, and so forth. Supports Mac, Linux, and Windows. And as you can see, it was already quite big already in 2019. So Helm is used by using charts, and the prerequisites are just to have a Kubernetes cluster and deciding what security configurations to apply to your installation, and if any, and installing and configuring Helm. And then a surprise sandbox project as a bonus, not even in the list in the beginning, we have Artifact Hub. So it helps you find Helm charts easily, and you can install and publish Kubernetes packages there. So the way Artifact Hub got started was Helm used to have its own Helm Hub, for example, and all of the different projects used to have their own Artifact Hubs essentially as well. But then everyone figured, this is a bit inconvenient to have multiple locations to host artifacts. So a single location was built and to became its own sandbox project where these can be managed really nicely. So now we have a really quick Helm demo. To kick us off, there will be 2 demos in the session. There will be Helm demo as well as a Kata demo. The other ones I am running through without demos. Perfect. Then let's find the correct terminal there. And let's get started. Let's hope that the internet is working nicely. I think everyone can see, hopefully. So we can see that yes, I'm logged into Azure. It's all looking good. Sometimes at this point I realize I'm not logged into the Wi-Fi, which is always a bit of a bummer. So we're good there. That's always perfect. Losing my voice a bit, but it's all right. So then we're going to do kubectl get services to then actually see that yes, we have an empty Kubernetes cluster and it's running in Azure. But it is empty because that's the point of this beginning part, to show you that it's empty, and then I actually do the installation there. But then we can actually do a fun kubectl get services all namespaces, and then we see that actually the container isn't even, the cluster is not empty. So there's a lot of Linkerd stuff there. I do a Linkerd demo as well. So that's why they are hiding there in the all namespaces there. So then we can also do Helm list, where we can see that there is no Helm releases either. So yes, everything is really starting from scratch. And then we would do Helm repo at Bitnami, but for me that has already been done before because I've done this demo before. So it's gonna just repeat there. And then Helm search repo WordPress, where we then see the available WordPress releases that we can then kick off with, and we will obviously use the one that's not deprecated. We were going to use the Bitnami one, and then we're going to actually do the magic. So Helm install Bitnami, WordPress generate name. So now this stage takes a few seconds more because actually a lot of things happen there. And now there's a lot of information there. It takes a bit of time for the WordPress site to actually spring up, but don't worry, we have things to do while we wait for that. And then we can do kubectl get services again to see that, yes, there should be something there as long as it has happened correctly. Perfect. Now we have an external IP that we can actually use to access our WordPress site because we want to get started on that block writing as soon as possible. Let's hop over here. Let's navigate here, and then it's going to take a few seconds or a minute or so to get started, but do not worry. As I said, we have things to do. So now, since we want to start that blog or whatever we want to do with the WordPress site, we want to actually, access it. We want to have the admin credentials. We want to get started with it. So you can see here, if I'm seeing from here, let's see, there we go. Oh, can't see from the side. So then we have the username there. So we know that one now. We're all good there. And then we're going to hop and take this one here, being very careful to get it, and then actually when we paste it here, we will then receive the password for our site. So that's very nice and convenient. Then we can see when this loads as well. So, but essentially what has happened throughout this demo already in this short amount of time, we have installed WordPress and MariaDB to our Kubernetes cluster, and configured WordPress and stored the admin credential security as Kubernetes secrets, and then revealed them, which is what happened there. And now if internet will allow, it should pop up soon, the WordPress site. Okay, something is not happening there. Let's see, let's refresh. Ooh, this is the exciting part of the demos always, but you know it's live then when things start to go wrong. Let's see. We can come back to it, because essentially what we would see a WordPress site ready to go, and we could use the credential that we just generated to actually log in there. Well, let's see. But yeah, let's see later if we get back to it. But something must have happened. I'll do the troubleshooting later on. I'm not going to bother you with that. Yeah, so let's continue. So Linkerd, which was new to, I think, or at least people hadn't used it before. Had anyone heard about Linkerd before this? Okay, one person, perfect. So Linkerd is a service mesh. So, and here is the site for Linkerd. And Linkerd is a graduated project as well, but it's much more recently graduated compared to Helm. So Helm is very, not an old one, but yeah. So Linkerd is a service mesh as mentioned before. So Linkerd is ultralight, ultra-fast, security-first service mesh for Kubernetes. And the overall goal is to reduce the mental overhead of having a service mesh to begin with. Linkerd, if you have ever heard Istio or Kuma or any of these service meshes, then it's similar to there, but obviously there's fundamental differences on how these things are built because they are different projects as well. But Linkerd is the first one and the lightest one. So what does it do? It provides observability, reliability, and as well as security. So the benefits are, for Linkerd particularly, there's a really thriving open source community that's really nice. And it has a very simple and minimalist design, so it's very easy to get started. So there's no complex APIs or configuration. The started guide literally takes minutes. There's deep runtime diagnostics, so you can get a comprehensive suite of diagnostic tools, including automatic service dependency maps, as well as live traffic samples. And it's ultralight and ultra-fast, so it's built in Rust. And Linkerd's data plane proxies are incredibly small, and they work really fast. It installs in seconds with zero config, as I mentioned before. So the control plane installs into a single namespace, and the services can be safely added to the mesh from there one at a time. And it has actionable service metrics, so best-in-class observability allows you to monitor colder metrics such as success rate, request volume, and latency for every service. So the principles here are that it just works, that it's ultra light compared to Istio, which is more feature heavy, but more a bit more heavy to use and impacts performance, for example, a bit more. It's very simple, and it's security first. So security is a default, not an extra. And Linkerd has a custom proxy, so Linkerd 2 proxy. So there's another CNCF project called Envoy. That's another proxy that a lot of projects use. But Linkerd has its own because it's meant to be very light and lean. So what's needed to use Linkerd? Just simply using this, and that's it. Injecting this, so that's exactly how easy it is. And now sometimes people ask me about, oh, have these projects, like how are they used in production? Are there any examples, or like which companies are using them and so forth? I'm not going to go into detail here, but there's a lot of case studies in the CNCF website. So there is, for example, Elkchöp they have using Kubernetes and Linkerd as well as Flux, which is another project in this session. So if you want, you can always hop in there to learn more if you're wondering. Does this work actually in production? Do companies like this? So this is a good way to learn more about that. So then we're going to hop on to KDA, which is a incubating project, but they're actually right now transferring or applying to their graduated phase. So they are like just getting all of the things needed so that they can move on to the next maturity state. So KDA, what is it? So default Kubernetes scaling is not really well suited for event-driven auto scaling, for event-driven applications, and Kubernetes is more for resource-based scaling, so CPU as well as memory. But this is exactly where KDA comes in. So it's event-driven scale controlling that can run inside any Kubernetes cluster. So it's very helpful because it can monitor the rate of events to preemptively act before CPU is even affected. And you can install it to new or existing clusters, and it has extensible and pluggable scalers to grab metrics from multiple sources. Now, the KDA principles are not to rebuild anything that Kubernetes offers out of the box. It's single purpose, simpler, non-intrusive, and it works with any container or any workload. Now I have a KDA demo as well, which is scaling a .NET or core worker with Azure Service Bus. And as you can see there, there's the simple architecture there. So there we have a lot of things. There's orders queue and so forth. But the way we can really think about this in the simplest terms, it's a web shop, but that's going to get a rush of orders. You know, it could be Christmas time shopping, it could be fall back to school shopping, whatever it is. And then KDA needs to handle that peak of new users there. And now since we need to switch our cluster for this, let's check in on the Helm demo last time and not be too upset if it doesn't actually load there. Yeah, no, something went wrong there. Perfect. But it happens, you know. But yeah, perfect. Then let's move on to the next demo. Let's keep really this time our fingers crossed that this one works. There we go. But we have to switch. We have to switch clusters. So let's actually close that one there. There. Then let's make sure that we are in the right cluster in all of these so that this one won't go badly. There we go. Perfect. It looks good so far. I can't really though see like every single word that's in the screen. I'm going by like memory, obviously, because it's a bit on the left. But perfect. So for the KDA demo, we need to get some information as well. So for this one, we need to do kubectl .NET there, and then really look closely at the external IP to get it correctly. Or did I miss a number there? I might have missed on the Helm as well. There we go. And then paste that here. And then let's now fingers crossed, because this is perfect. Now it's looking better. There we have the order queue length there. So we'll see the peak there. And then we're going to do kubectl get deployments namespace KDA there to actually see the order processors, being how many of them are in use, so that we can see how well we're doing the auto scaling. And we're going to do kubectl head pods there, and there we see how many is running there. Let's see. Perfect. And then it's all looking good so far. And then we are going to start actually the action. So this is all kind of set up, and the action will be very fast. So hold on to your hats, keep looking at the screen. But first we're going to do .NET Run project KubeCon demo. I did the demoing KubeCon for the first time, and then it's asking us, let's queue some orders. How many orders do we want? We want 100 orders for our back to school rush. We click yes, it's all coming. Then we see a chips order coming in for Desmond, and then now they're all peaking super fast. There we see all of them coming in. We see the order queue getting higher and higher. So many things happening at the same time. And then Kata should be kicking in to start auto-scaling things. There we go. So we have here, there are pending, and it's starting the container creating status phase. We see even more pending and so forth. We see 4 out of 4 order processors ready. We see the orders peaking at 100 as we ordered, so that many exactly. Then we see it going down because we're actually managing to process them because we had 4 out of 4, but now we realize, oh, we need even more. So we have 8 out of 8 order processors ready. And now we're switching from the container creating and the pending to running status mostly. So then it's at 8 out of 8. It might go to 10 out of 10. Perfect, 10 out of 10. And it's getting closer to 0 there. So we're really handling all of the order queue very nicely and fast. There we go. And we have handled the queue very nicely. Thank you, Kata. So we have 10 out of 10. And now obviously the auto-scaling up is very important. But auto-scaling down is very important. Well, that obviously saves you up on resources as well as costs. So if you're not using compute unnecessarily, as well as it's really good for the environment as well. So it's actually very sustainable if you're using auto-scaling, because then, you're not using compute unnecessarily as well. So, and then that's why Kata will start to auto-scale down in just a matter of a few minutes or so. But we are not going to wait for that because that would be very boring watching just this screen for like a couple of minutes, and then it's just going to show essentially deleting, and that's it. So we can maybe live without that. So yeah, perfect. That demo at least went really well, so that's really nice. You got at least one nicely working one today. That's good. So that was Kata, scaling .NET Core worker with Azure Service Bus. So then we have really great upcoming projects as well. So yeah, we have Flux, which is the GitOps family of projects. So Flux is another incubating project, but it's been incubating for quite a long time now. It's quite well known, and it's already essentially recommended for production in a lot of different places, but it is still in the incubating phase officially. So Flux is centered around GitOps, as mentioned there as well. So what is GitOps then actually? So you have all of these multiple CLI tools like kubectl apply, kubectl set image, Helm upgrade, kubectl upgrade, and you can essentially replace all of them with Git, so with Git push, for example. So what does it mean? It means instead of changing the state of your cluster with multiple things, you can use one command to modify something and push it to your Git repository, and therefore it will then go up to the cluster. So this can be anything from namespace or so forth. So with Git, you obviously have a nice history of what has happened to your cluster as well. So GitOps really provides one model for making infrastructure, apps, and Kubernetes add-on changes, and you have a consistent end-to-end workflow across your whole entire organization. So in a nutshell, you have like an easy snapshot of your cluster that you can restore to, so if anything happens. So if you lose a cluster, you just plug into your new cluster to Flux and you restore everything. Not quite everything, obviously, no stateful sets, no databases, and so forth, but everything that was in the Kubernetes memory essentially will be restored. So it's kind of like a desired state, so kind of like a save point where you restore to. So why is Flux particularly great for GitOps? So Flux project aims to provide complete continuous delivery platform on top of Kubernetes and support all the common practices and tooling in the field. So customize Helm metrics with Prometheus and so on. Because I think the least one, no one wants more complexity and more different things to use in that way. So Flux is a project that has seen a lot of changes in the past as well. So it used to be a monolithic infrastructure, but nowadays it's a native microservices, and it has been rewritten from scratch between Flux version 1 to Flux version 2. So a lot of the practices and the benefits here are that it's helping define GitHub practices, so describing your system declaratively, keep configuration under source control, and use software agents to reconcile and ensure correctness and alert for drift. As well as the benefits there are that you can actually collaborate on infra, you can have access control, auditable history, drift correction, and clear boundaries between the dev team as well as Kubernetes. So those are some of the flags. And as I showed in the previous case study one, for example, LCHEP was using Flux as well as Linkerd in their world. So yeah, next up we have KubeVirt. So we have building a virtualization API for Kubernetes is the tagline here. So what is it actually? So if you are working in a team or a company where you actually have to use a lot of legacy projects as well, because legacy will definitely not go away like with a single touch of a button. You have to actually enable work to be working with both of these things. So you have to work together with the legacy as well as the new containerized technology if you want to do that. KubeVirt provides a unified development platform where developers can build, modify, and deploy applications residing in both application containers as well as virtual machines. And it's declarative, so it's kubectl again as well. So it really helps you by managing virtual machines for impractical to containerize apps, and you can combine existing virtualized workloads with new container workloads on the one platform, and it supports development of new microservice applications in containers that interact with existing virtualized applications. With virtualized workloads placed directly in the development workflows, teams can decompose them over time while still leveraging the remaining virtualized components as desired as well. So that's KubeVirt. And then we have Kudo, which is and KubeVirt is a incubating project as well. And then Kudo is a sandbox project. So it is Kubernetes Universal Declarative Operator. So you can maybe see the naming there with Kata as well. It's kind of funny that they're so similar sometimes. But yeah, Kudo is really about stateless versus stateful apps. So if all apps were stateless, everything would be really simple, but not all apps are stateless. That's just the reality where we live in. So stateful apps needs logic, specific knowledge to run a certain application. Kafka might be different from Cassandra and so forth. So Kubernetes has been very focused on stateless, and stateful apps do not really play well together with it. So Kubernetes created stateful sets to fix this issue, but it does not solve the fundamental issue, and operators were kind of brought in to fix that. So operator manages and monitors the life cycle. It requires a lot of custom knowledge to build an operator because it takes a lot of development power. So each operator is unique and it's purpose built for each application. So it's very heavy in development time needed. So it might require even like 1,000 lines of code, for example. So substantial engineering resource is needed for them. So Kudo then comes here. So rather than using a custom operator, Kudo provides a universal operator with the concept of the plans built into it already. So it helps really there, which means hence why the name Kubernetes Universal Declarative Operator. So the benefits here are that Kudo can create operators without needing deep knowledge of Kubernetes or coding by defining the lifestyle stages. It's just Kubernetes APIs, so it's a lot easier to learn. And it has Kubernetes native management, aka using kubectl and other familiar tools as well, which is a big theme, I think, across all the projects. This is when you can use familiar tools, you can actually get started easier. Then we have Meshery, which is a sandbox project as well. It's the newest project, I think, from the sandbox projects in this presentation. So Meshery is, joined the CNCF, I think, a year ago-ish exactly. So it's quite new. And it started off, let's say, with a bang, even though it's quite new. So it's quite popular already. But Meshery is service mesh management plane. So service mesh, as Linkerd I showed before, is the control plane and the data plane. But then Meshery then adds the management plane there. So the management plane provides federation, integrates with backend systems, may help perform chaos engineering, and provides deeper insight to the performance and long list of things possible to do. Now, if you're wondering why would I use Meshery, if you're using a service mesh already, well, Meshery is specifically built if you have a lot of service meshes that you need to use. The reasons might be, you know, legacy, if there's a personal preference within the team members on what to use or what not to use, like if someone wants to use Istio and someone wants to use Linkerd. So if you have more than one type of service mesh running in your inside one cluster. So this is where things get very messy, so Meshery then adds there. Now, obviously, a lot of people usually come up to me and say, well, okay, you're trying to solve complexity by adding more complexity, which is maybe obviously one can think about, like, when is it ideal, when is it not? So, but then it obviously, as always with IT, it depends on your needs and what kind of setup do you have and do you actually need it. But it is nice to, I think, in my opinion, to know that it is an option because it's an issue that teams, though, face quite often. So Meshery supports over 10 different service meshes. It has multi-mesh management, so lifecycle workload, performance, configuration, patterns and practices, as well as chaos and filters. And it is still on the way to complete architecture last time I checked. Now, as mentioned before, Meshery did take off very fast. It is, even when it was kind of kicking off, it has very active group of maintainers and companies backing it, which means that it also has, for example, it's the most popular project in the Linux Foundation mentorship program. So definitely one of those cases where it's very early on, but there's a lot of indication that it's going to be like a long-lived project because of such an active community behind it. Another one of those examples in the sandbox phase, because truly in the sandbox phase there's a lot that can happen. Things can go either way, but another example of a project with really active community that's really working hard on the project and talking about the project a lot and increasing awareness is Kyverno, which is Kubernetes native policy management. So if you're looking into security for Kubernetes, this is a nice help there. The maintainers are incredibly active. They constantly help out people and they work a lot with CNCF as well. So Kyverno is designed for Kubernetes and it's the policy engine designed for Kubernetes. So policies are managed in Kyverno as Kubernetes resources and no new language is required to write the policies. So this allows, again, for familiar tools such as kubectl, Git, and Kustomize to manage the policies. So the policies can validate, mutate, and generate Kubernetes resources, plus ensure OCI image supply chain security. There's a lot of great list of sample policies that one can use as well. So it's really great if you're looking for security of your cluster. Yeah. Now we still have a bit of material to go through, but now we're gone through all of the projects that I promised to run through. I think this is actually missing KubeVirt. I think this list as well as Kyverno. But yeah, so we went through a CNCF overview. We went through multiple projects as well as the bonus of Artifact Hub. So it's been a very, as I said, very hopefully fast-paced enough so that everyone stayed awake, even though it's Monday morning. And then, as always, there's a lot of great Learn More resources that one can look into. So the CNCF survey, as I mentioned before, is always a hoot. Every time I check it out, I learn something new. You can always also find peer support from there because, for example, usually the finding on what is the most challenging part about using Kubernetes, usually the answer is complexity and whatnot. So it's always nice to be like, I'm not alone if things seem complex and there's a lot of things happening. All the projects have their own sites. I highly recommend checking those out as well as learning more about them. Supporting your favorite projects in GitHub is always very important because obviously open source maintainers are doing this for free from their own free time. So actually supporting the project is really important. You can check out a lot of the case studies in the CNCF site as well. And if you're interested in this future predictions side of things, so there's a CNCF end user technology radar, which is also which is a new, relatively new project that looks into what all end users are using within a certain space. So for example, for security. And then it kind of makes a recommendation. Okay, so many end users are using this in production already, so people can use it as well. And for example, even though Flux is incubating project, it's being recommended by the technology radar, which means that it's already used in production by a lot of companies. So that's really nice. And if you're interested even more in this future things, so there's always a technical oversight committee usually does a session, predictions from the technical oversight committee, for example, by Liz Rice, which then really talks into like, okay, what's hopefully and what's likely to be happening in the future of Kubernetes space. Obviously, I've incorporated a lot of that into this session as well. If you are a beginner to Kubernetes and cloud native topics, I highly recommend checking out Tech World with Nana. They have a lot of good content in YouTube, as well as there's obviously really a lot of great courses in other locations as well. And I very often spend a lot of time in CNCF YouTube. There's a lot of good content there, and as mentioned, kind of teased in the beginning, there's also teaser longer introduction to sessions. So if you have KubeCon, you usually have a maintainer, for example, a KDA maintainer doing an introduction to KDA, 30-minute session, and then maybe a deep dive into KDA, 30-minute session. You can find all of those on YouTube for free. So if any of these projects piqued your interest, you can, hop on over there and learn more there. As always, I put all of my links and slides, well, the links are in the slides, to my GitHub, so you can find them there. And then a recommendation here is, so the podcast that I mentioned at the beginning, I did an episode of Tom Kirkhope, which is one of the maintainers of KDA. So particularly I like this episode because it fits so well with this session, particularly. Like if you were thinking about, all of these open source projects, what do the maintainers think? How does it feel working with CNCF? What does it all mean? Why do maintainers do what they do? Then this episode was really great. I learned a lot from Tom. So Tom is a KDA maintainer, and he was very candid with how he's uniting family life with open source maintaining, as well as thinking about questions such as like, what happens if he dies? What happens to KDA? What happens? Very morbid, I know, but really important to kind of think about the consistency for open source projects. So it's very interesting in my opinion. But yeah, we are finishing a bit early, but you can come up here and talk to me and ask questions. So we have a bit of time for that, which I think is also kind of nice. Or you get a nice breather before the next session. So, but yeah, the one thing to take away here is inspiration, inspiration, inspiration. I hope everyone got some of that and have a great conference today.